In this video, we're going to learn how to design a computer vision algorithm to produce artworks. In other words, how to perform the so-called style transfer. Painting is a popular form of art. For hundreds of years, people have been attracted by the art of painting with the advent of many fantastic artworks, such as these two depicted on the slide. In the past, redrawing an image in a particular style manually required a well-trained artist and lots of time. Recently, inspired by the power of convolutional neural networks, a researcher whose name is Gauthier first studied how to use CNN and gram matrices to reproduce famous painting styles on natural images. Their proposed algorithm successfully produces beautiful stylized images with the appearance of a given artwork. In style transfer problem, a content image C and a style image T are presented. The goal is to produce an output image X, keeping the global structure of content and local patterns according to style, for instance, color and texture. One question is, how would content and style contribute to the output, and how the style is even described within this contribution? To match image content, a content similarity between images should be defined. For style transfer, we extract content targets represented by activations at a certain layer in a pre-trained convolutional network such as AlexNet, network pre-trained on ImageNet. For instance, at layer conv5 in AlexNet, we will obtain 13 by 13 by 128 array of feature activations. We then measure content similarity using Euclidean laws in the space of feature activations induced by input images. To match image style, we should exploit a correlation statistics from feature activations induced by input images. To compute the correlation statistics, we use the gram matrix representation. Gram matrix is the matrix of dot products between vectors of feature activations at a certain level. We measure style similarity again using Euclidean laws in the space of feature activations represented by gram matrices. In practice, activations induced by multiple layers may be weighted to produce a nicer result. Our loss function is therefore sum of two losses for style and content parts. Style loss implies reproducing the same low-level correlation statistics as in the style target. Content loss function enforces that our generated image generally looks like the content target input. What else do we need to generate the resulting image? We have a loss function which evaluates how close our generated image is to the desired one. Then we can minimize the loss, and since the loss we have introduced is a differentiable function, we can use gradient descent and start from original or noise picture. Note the variables we are optimizing to minimize the target function are the image pixel intensities. The original texture is passed through the CNN, and the gram matrices GL on the feature responses of a number of layers can be computed. Then a white noise image or a content target image X is passed through the CNN, and the loss function EL is computed on every layer included in the style model. The total loss function L is just the EL or a weighted sum of the contributions EL from each layer. Using gradient descent on the local loss with respect to the pixel values, a new image is found that produces the same or close gram matrices GL as the original style. When only constraining the style representation on the lowest level, the synthesized style has little structure, and is similar to spectrally matched noise. If we increase number of layers on which we match the texture representation, we find that we generate images with increasing degree of naturalness, such as the one of the young lady here. To summarize, style transfer is an optimization technique that is used to paint the natural images using a style of an artwork or any other style target image. Its target is to produce an image that is close to two target images, the style and the content targets. we generally aim to match feature activations induced by the generated and the target images at two different layers in a pre-trained convolutional neural network. The image is generally produced via gradient descent in the pixel space.